Hi, my name is Rachael Gold, and this is my surf experience at the University of Florida. I'm a rising senior at the University of Buffalo studying aerospace engineering and math, and there I work in the UB Nanosatellite Laboratory as the mission operations lead for one of our ongoing missions. I also work under Dr. Eleanor Abada on validating the deployment phase of her Space TetherNet simulator. I've also done internships at the Air Force Research Lab and MOOG in the past. This summer, I worked in the Advanced Autonomous Multiple Spacecraft Lab, or ADAMUS lab, under the direction of Dr. Ricardo Bevilacqua, and my PhD mentor, which is pictured here, is Camilo Riano Rios. In order to properly discuss my project, I need to address some of the previous work done. The D3, or drag deorbit device, which is pictured on the top right, is an actuator that uses differential drag to control a satellite's speed and position in low Earth orbit. The uses include attitude and orbit control, controlled satellite deorbiting, and formation flying. My PhD mentor Camilo developed controllers for two purposes. The first is a controller that sends n number of chaser satellites to rendezvous with a target satellite, which is pictured on the bottom right, and the other controller stabilizes the attitude of the satellites. The rendezvous controller needed to be validated against a more confident orbit and atmospheric density model. Systems Toolkit, or SDK, contains these models. So my tasks are to visualize orbit data in SDK with the atmospheric density and orbit models already included in the controller. Next, to integrate the controller into SDK in order to use SDK's atmospheric density and orbit models. Next, to visualize attitude data in SDK. And finally, to complete my own proportional derivative and linear quadratic regulator controllers for fly-around, rephasing, and rendezvous maneuvers. This video shows a visualization of the ephemeris data generated by the rendezvous controller. In this case, there are 4 chaser satellites and 1 target satellite. In SDK, you can see the D3 model attached to a 3U CubeSat. This slide details the layout of the rendezvous controller validation code. First, I initialize SDK and create a scenario. Next, I create the target satellites and n number of chasers. I'll set the propagator to astrogator, specify the initial conditions, and add an initial state block to astrogator. Run the MCS, import the states from SDK into MATLAB, run the controller, add an update block, then propagate the new orbit. Finally, I'll import the states again and continue looping until the controller finishes. In the videos here, you can see the result of the validation code. The video on the left shows the area changes in one of the satellites, and the video on the right shows the 5 chaser satellites coming to rendezvous with the target. The following graphs further prove the validation to be successful. The graph on the left shows that all of the states are driven to 0, which is the goal of the rendezvous controller. And the graph on the right shows that the area inputs also converge to a common input of 0.25 meters squared. This slide shows some more of my accomplishments for this summer. On the left, you can see the visualization of the attitude, and on the right, you can see one of the 6 controllers that I wrote this summer, and it is the 2-input LQR rendezvous controller. I will graduate this May with degrees in both aerospace engineering and math. Once I graduate, I intend to pursue a PhD in aerospace engineering with a focus in either space debris or small satellites. Once I gain my PhD, I would like to work at a research lab. Some examples of places I would like to work are the Air Force Research Lab, NASA, Johns Hopkins Applied Physics Lab, or the Aerospace Corporation. As I close the program, I'd like to thank Dr. Bevilacqua and Camilo for guiding me on my project this summer. I'd like to thank AGI for all the help with SDK. Thank you to Mike, Julissa, Brittany, and the Provost for funding, for making logistics easy, and hosting all the surf events. Finally, thank you to my friends for making my summer outside of work fun.